Hello students, welcome to what may be the final packet review video featuring my hand. It's Friday 3/27. This is the last thing that we studied before we went on break. So probably it's a little confusing to you. But luckily, you have this great box here that is reintroducing you to all these different types of shapes, all these different types of quadrilaterals. Remember, quadrilaterals have 4 sides. And it gives you a description of each type of shape and their attributes. So this is extraordinarily valuable to you. Right, so make sure you're referring to this box and these different attributes of each shape when you're deciding how to categorize the shapes on the bottom and on the next page. So I'm going to go to the next page because these are getting a little bit more difficult on this page. And let's see. Let's go to number 5. Zoom in here, and I have this shape. And I think this one's the trickiest one. That's why I chose it, because it almost looks like it has 4 equal sides, but almost isn't good enough, right? I think I can see that this side here, these 2 sides on the bottom, are a little bit longer than these sides here. So that means it doesn't have 4 equal sides, right? These sides are longer than these sides are a little shorter. So then it can't be a rhombus because it doesn't have 4 equal sides, because that's the definition of a rhombus. A rhombus is any shape that has 4 equal sides. And it also can't be a square because the square has 4 equal sides. And the square has right angles, right? And this doesn't have any right angles at all. Okay, so then the question becomes, is it a parallelogram or is it a quadrilateral? Well, quadrilateral is easy because for that one we can just count. We got 1, 2, 3, 4 sides. Yup, it's a quadrilateral. Parallelogram. Alright, now this is getting tricky again. And this is definitely the hardest one here. Is this a parallelogram? Remember, a parallelogram means that it would have 2 sides that are parallel, which means like those 2 sides would go on and on forever, just like these 2 L's, and never touch each other, never intersect. And for this shape, it almost looks like a parallelogram. Almost. But again, just like it almost looks like it has equal sides, almost just isn't good enough, right? We want to know exactly. So like if we were to draw these lines, and we had them just keep on going and going and going, you can see they're actually getting closer and closer together and further apart. If they were 4 equal sides, then it would be a rhombus and it'd be a parallelogram, and the lines wouldn't do that. But because these sides are shorter, it's not parallel anymore. And so this is not a parallelogram. This is a really tricky one because it almost looks like it could be a rhombus and it almost looks like it could be a parallelogram. But if you look really closely, you can see it isn't. Okay, so be really careful about that. That was a tricky one. Let's do one more. Okay, so use the quadrilaterals for 7 through 9. So you're using these quadrilaterals here for these problems. Let's talk about right angles a little bit. So let's look at number 7. It just says, which quadrilaterals appear to have no right angles? Not even one. Okay? Remember, a right angle is a corner that you could put a little square in, right? So another, like a synonym for right angle that's sometimes used in the math books is square corners. Which ones have no right angles? Well, this one has 4 right angles. So A is not one of our answer choices. B, does B have any right angles? No, I can't put any squares in here. They wouldn't fit neatly. We've got 2 obtuse angles, which remember, obtuse angles are greater than a right angle. It's more open. And then we have 2 acute angles. Remember, acute angles are smaller than right angles, right? They're a little tighter than right angles. What about, so B would be one of our answer choices. What about C? Again, C, you can see you have 4 right angles. It's a square. D, do we have any right angles here? I mean, it's close, but I mean, if you remember with these, you could check with like the corner of your piece of paper, because it is a square, and I know it's hard to see because it's white on white. So let me shade that in a little bit. If you see, if I try to put this square corner in there, it's a little bit bigger, right? This is actually an obtuse angle. Again, got 2 obtuse angles and 2 acute angles. So D is another one that we can add to our list. And now for E, well, again, we don't have any right angles here. We have 2 acute angles at the top, and we have 2 obtuse angles at the bottom. So it would be B, D, and E. And again, you could check by just using the edge of your piece of paper, and you can see, like, alright, is this going to fit perfectly here? Will I have a nice square corner? No, this is a little bit bigger. We have an obtuse angle here. What about this top one? Do I have a square corner? No, this is bigger. It's an acute angle, right? It's smaller than what this square corner would be on the edge of my paper. So it's a good idea. If you're not sure, you can use the edge of a piece of paper to figure out if you can if you have a right angle there or not. Like you see for the square, fits perfectly. I have a right angle. Same thing for the rectangle here. Fits perfectly. You've got a right angle. For the others, it doesn't work like that. Alright, let's turn the page. Saw a nice one. What was it? Oh, yes. Okay. Sticking with quadrilaterals. Series 7, page 6. We've got this problem, which is on the same topic. A rectangle is split into 6 parts. Which parts of the rectangle are parallelograms? So, blank parts are parallelograms. Remember, a parallelogram has 2 pairs of parallel sides. And parallelogram is also a quadrilateral, right? So, if you look at P, well, P is a triangle. So it's definitely not a parallelogram because it doesn't have any pairs of parallel sides, and it's not even a quadrilateral. Let's look at Q. Does Q have 2 pairs of parallel sides? Well, this pair is parallel, so there's one. What about the top? Yes, there's another one. So Q is a parallelogram. I'm just going to label it with PAR for parallelogram. R, let's check. Well, here is one set of parallel sides. The top and the bottom are parallel. What about the other 2 sides? No, definitely not, right? These are going to crash into each other right up here and get further and further away. So it's only got one set of parallel sides. This is a trapezoid. And you can see that S is actually the same as R. It's just flipped upside down. This is another trapezoid. It's got parallel sides on top and bottom again, but side to side they would intersect at the bottom and get further and further away from each other at the top. So far we have a triangle, a parallelogram, two trapezoids. Now we're on to T. Is this a parallelogram? Let's check these sides first. Well, these two sides are parallel. Looks like they'll go on forever without ever touching each other. And the top and the bottom are also parallel. So it looks like Q is our other T is our other parallelogram to go along with Q. And then you can see U at the end. This isn't even a quadrilateral, it's another triangle. So it's definitely not a parallelogram. So your answer is Q and T, which is B. Q and T. Alright. Let's look at number 7. Alright, we've got a bar graph here. Remember, the first thing you're going to do with a bar graph, after you read, of course, is to label your totals. And in order to label your totals, you got to look at your scale. Alright? So let's be really careful when we're doing that, and hopefully you were already, since this is review. First, let's read. Aida is graphing the lengths of 4 strings. The bar for the length of the first string is missing. Alright, so this bar is missing. This is what we're looking for. The 4 strings are 66 inches long combined. So all 4 of these together is 66 inches long. This is your total. Which bar completes the graph? So we want to know that which bar here is going to make this total equal 66 inches. So really this is like, again, it's like a part whole. So you have these 4 parts right here, and all together added up, this plus this plus this plus this should equal 66. Okay, well, now we have to figure out what each of these bars is so we can solve to see what the first bar should be. Alright, so now we've got to label our totals here. But in order to do that, we have to look at our scale. Because like this one right here, well, here's 8, right? So is this 9, 10? Is this going to be 10? Should I write a 10 right here? Somebody, you better stop me. You better stop me. Because I definitely should not. Because this isn't a scale that goes by ones. Or else you'd see that this would be 0, 1, 2, 3, 4, but there's an 8 there. So obviously this isn't going by ones. It must be going by twos. So this is 0. Here's your 2, 4, 6, 8. Yes, it's going by twos. 8, 10, 12. So right here, you could label 12, right? This bar is 12. And you can keep checking. 12, 14, 16. Yes, okay, this makes sense. And whoa, that's this one right here is 16. Okay. And I can draw a little line across just to make sure. Yep, that's 16. And keep going. And you got 18, 20, 22, 24, which is where this one lines up. And you can draw the line across, but be very careful. Like, don't veer too much up or down. You might end up confusing yourself. And so now I know my totals. Right? This is 24, this is 16, this is 12, and all of these added up plus this one should equal 66. So this is now like part whole. So let's add these together. 24 plus 16 is 40. Alright, 4 plus 6 is 10, 1 plus 2 plus 1 is 4. These 2 is 40. Now we got to add the 12 as well. Plus 12 is 52. So if all of these together is 52 and our total is 66, then we could subtract to find the difference, and then we'll know what our missing bar should be. 66 minus 52, 6 minus 2 is 4, 6 minus 5 is 1, so it should be 14. So now I look down here, I'm going to figure out which bar is 14, and you can see, conveniently, it is A. because you get 8, 10, 12, 14. A is our answer. Perfect. And you can check the others just to make sure. That's all.